Hello guys, and welcome back to our video lecture series on principles of communication. In this video, we are going to discuss single sideband generation techniques. This will be the last module under the single sideband systems. There are three methods of generating a single sideband signal. First, we have the filter method, the phase shifting method, and the Weaver method. Each method employs a balanced modulator to suppress the carrier. The transmitters used for a single sideband suppressed carrier and reduced carrier transmission are identical, except the reinserted carrier transmitters have an additional circuit that adds a low amplitude carrier to the single sideband waveform after the suppressed carrier modulation has been performed and one of the sidebands has been removed. The reinserted carrier is called the pilot carrier. The circuit where the carrier is reinserted is called a linear summer if it is a resistive network, and a hybrid coil if the single sideband waveform and the pilot carrier are inductively combined in a transformer bridge circuit. The simplest and the most widely used method of generating single sideband signals is the filter method. The figure here shows a general block diagram of a single sideband transmitter using the filter method. The modulating signal, usually a voice from a microphone, is applied to an audio amplifier, the output of which is fed to one input of a balanced modulator. A crystal oscillator provides the carrier signal, which is also applied to the balanced modulator. The output of the balanced modulator is a double sideband signal. A single sideband signal is produced by passing the DSB signal through a highly selective bandpass filter that selects either the upper or the lower sideband, which is then amplified and then fed to an antenna for transmission. The quality factor of a single sideband filter depends on the carrier frequency, the frequency separation between sidebands, and the desired attenuation level of the unwanted sideband. Q can be expressed mathematically as the following equation here, where Q is the quality factor, F sub C is the center or carrier frequency, S is the decibel level of suppression of unwanted sideband, and delta F for the frequency separation between the highest lower sideband frequency and the lowest upper sideband frequency. For an example, let's try to solve this problem. Determine the quality factor Q necessary for a single sideband filter with a 1 MHz carrier frequency, 80 decibel unwanted sideband suppression in the following frequency spectrum. Here, in this problem, we're given a carrier frequency of 1 MHz, and we have unwanted sideband suppression of 80 decibels, and we have a delta F of 200 kHz. Substituting the formula given earlier, we get 125,000. The phasing method of single sideband generation uses a phase shift technique. This is the mathematical representation of what happens in a phase shifting method. Essentially, when you add the sign expression given previously to the cosine expression just above, the sum frequencies cancel and the difference frequencies add, producing only the lower sideband. The last method is the reverse method, or the so-called the third method. In this, the band of interest is first translated to be centered at zero, conceptually by modulating a complex exponential e raised to j omega t with a frequency in the middle of the voice band, but implemented by a quadrature pair of sine and cosine modulators at that frequency. This complex signal or pair of real signals is then low-pass filtered to remove the undesired sideband that is not centered at zero. Then, the single sideband complex signal centered at zero is up-converted to a real signal by another pair of quadrature mixers to the desired center frequency.